Hello, welcome to Deep Learning with PolyAI. Today we're going to get a little bit more technical than usual. And the reason for that is recently Andreessen Horowitz published their thesis on AI voice agents. And in it, they give a pretty good overview of the AI tech stack. And it's a lot more than just LLMs. It's actually pretty complicated. So I've asked Shawn Wen, co-founder and CTO at PolyAI,
Hello.
to join us today. Hi, Shawn. And help us to get a better understanding of what's involved in making really good voice AI. So, Shawn, just to start us off, for anybody who's thinking about building or buying a voice assistant, could you explain a little bit about what that tech stack should look like?
Yeah. And yeah. So yeah, my name is Shawn, co-founder and CTO of Poly. So in terms of like buying or building voice AI, like especially you have to first thinking about the channel. Like if it a phone call channel, which is like predominantly the contact center business would run into, then you will have to think about how do you pipe the audio from your contact center into the voice assistant. And usually the voice assistant should be living in the cloud. Sometimes you can do on-prem deployments as well, but predominantly it's in the cloud. If it's in the cloud, the most easy way is probably through the SIP connection, so that you will have an IP address of the voice assistant, and you can pipe the audio. Or if your voice agent vendors also provide you for the PSTN redirect, then they will host a phone number somewhere with a telco partner, and then you just forward that call into that number. That's another way. So once you get this connection set it up, then you go into the real meaty bit of the entire voice assistant, because it's the voice assistant, right? So you technically need the voice bit, which is containing what we call the speech recognition or speech to text module, basically transcribing your live audio into text. Usually this should be a streaming endpoint so that you will be able to transcribing the speech as soon as you get the audio chunks, rather than waiting for the entire audio. A lot of times when the latency happens, this is like the number one thing that you should check. Are you actually doing a streaming endpoint, or are you actually just waiting for the entire audio to be sent into the cloud? So that's the speech to text bit. And then
Shawn, when you say the streaming
yeah,
audio, do you mean that it's waiting? It's sorry, as the caller is speaking, it's transcribing it rather than waiting for the caller to say what they're done saying.
so basically, it mean when I say streaming architecture, that means that as soon as you get the first audio packet, you should just send it to the cloud, right? So like you have a streaming protocol that as users speaking over the phone, you don't need to wait for the entire user speech
Yeah.
be finished to send the entire message into the cloud. You started to saying, when I started to say hello, you say hello piece already to a cloud. So the model has already recognized it. So that by doing this kind of streaming architecture, you can actually minimize the latency, and then, have a very good user experience around.
That makes sense, and I think it's more difficult than I thought. I thought you just, like, plug in the ASR, right, and then it just works, but you have to think about what is the right way
That's right.
to
Yeah.
turn that on.
And
Wow.
also, there's a lot of there's a lot of pitfalls in choosing the speech recognition models for the purposes. Despite that, all the speech vendors will tell you that they have the lowest word error rate, which is like usually how they measure a speech recognition system's performance, right? The problem is that these kind of speech models are trained based on different kind of data, right? So let's say if you have a British accent voice assistant, because your majority of your callers are actually with that accent, then a model that's trained based on US in English is probably not ideal, right? So there's a lot of like these nuances. And for example, in UK, you also have a lot of regional accents as well. And those regional accents, if it's not part of your training data, which is predominantly a case because majority of these speech recognition vendors are actually serving US market predominantly. then you are going to struggle to recognizing some of the even basic simple words like yes or no, or in Scotland, you will say I, right? So these are the problems you will run into. And then, if you don't know the nuances of it, you don't know how the model is trained, then you are going to hit a lot of roadblock.
Right. So do you have to use multiple models then to serve all of your audience?
Yeah. So basically, what we do is, specifically for in English, right? I think if you are, serving different languages, you definitely need, different kind of models. Despite the fact that now the so-called end-to-end speech recognition model becomes more and more popular, and then you will be able to train a multilingual ASR on top of one single model. This is what the Whisper model, OpenAI, is doing, right? There are still some challenges there because, like then in this case, they started to transcribe some mixed code speeches, so for example, like maybe they will transcribe, the full English sentence into English to Mandarin mixed the text. And that caused some challenges as well. And also these models, I think we are still at the early stage of those models because the latency and the compute intensiveness of those models are still an engineering challenge to be overcome. But I think it's becoming more and more mature. But a lot of the production systems you are seeing these days are basically tailored to that particular regional accents or particular language per se. So, for example, in our deployments, we have British deployments, we have the US deployments, which also align with the data privacy quite well because you kind of need to keep the user data in that the particular region anyway, and then you deploy different models for that purpose. And for each of those regions, we actually have a lot of this kind of like, user data that is available to us. And then we will be able to continue to improve that model in that particular region.
Wow. Okay. So a lot to think about just in terms of speech recognition there, getting the right vendor,
That's right.
model.
Yeah.
Okay, cool. So you've got your speech recognition. That's one part of your tech stack.
Mhm.
What's next?
Yeah. So then, usually speech recognition would also come with a small technique. It's called voice activity detection. This is called VAD. This is basically a model that decides when to stop listening and then tell the next model saying that, hey, now is the end of that user speaking. Now you can start speaking. Right. So that's another challenge as well, because you can imagine if that model is not accurate enough, you'll probably wait for too long, so you cause higher latency. If you are waiting for too short, then you are going to interrupt your users. And also depends on your users, right? Like, the elderly people will tend to speak slower. Then you need to factor that into your data design of the system as well. So there's more to consider just in itself.
Yeah, that's amazing. There are times when I'm on like a Zoom call with somebody
Yeah.
and I have to go, "Are you still there? Have you frozen?" Because they're just thinking about how they're gonna finish the sentence, right? And that must be so difficult. And that's with somebody that I can see,
Yeah.
let alone somebody over the phone. You can't see them, you don't know what they're doing.
That's right. And then, as humans talking to each other, you will actually adapt to that person's, the way of their speaking as well. I
Yeah.
think voice AI, you
Yeah.
have to think about who are your users, and then do they prefer to have a faster iteration or, a slower pace of conversation? So I think you see a lot of like, new platform companies, they're optimizing for latency.
Yeah.
All we are saying is that's, a shorter latency, maybe not what you need, right? Maybe your user would actually tend to pause for a very long time to actually think about it. So if you project yourself, as a developer, you want things to be fast and punchy, right?
Yeah.
But you shouldn't project yourself when you design your system.
Yeah, that's so interesting because you take into account as well the fact that people don't know how to speak to voice technologies, right? They've been trained to speak to them in keywords or in this really stilted and awkward way.
And
Um,
in reality, that we found that a lot of our users going into contact centers, when they pick up and then they notice it's a voice assistant, they kind of pause for a little. They're wondering what the hell's going on?
yeah.
What's the IVR system I get used to? shouldn't I press 1, 2, 3?
Yeah.
Right. So
Okay, cool. So you've got that speech recognition part. You have this part where you're saying, how long should I be listening for? And then what happens?
then, once you transcribe it, it's basically transcribing into text. And that text then would be sent in the modern conversational AI architecture with a generative AI. You send it to the Gen AI models.
Yeah.
Usually before that, there's also some sort of other things you wanted to do, like, the safety guardrails, the content filter. You want to make sure that those sentences are actually not harmful or, not intended to do prompt injection and things like that.
Right.
You have a extra safety guardrail there before LLM. What we do at Poly is that we don't, because our clients are enterprise clients, they are very adamant about how can I gain control over what the voice assistant to say. So before we feed it to LLM, we also have a proprietary dialogue framework to actually decide based on, the context of the conversation, what the bot should be doing, right? So we have what we call so we have the rack component. So basically is, like a normal like rack kind of system where you put the user queries into the rack, and then the rack would actually return you the top 5 or top 10 results, right? Depends on how you configure it. And that result would then be fit into part of the prompts with LLMs. But then we also have a techniques called talk track. So the talk track is kind of like, we are still thinking about the branding of those terms. So, Kylie, we will need you will have more on that one in the future. But think about like, when you go on to the stage to give a speech,
Yeah.
you either wanted to have like the major topics you wanted to talk about in that for that audience and in that conversation. So you take those notes. That's basically what we do. But the notes we are taking for the voice assistant, it's much more structured. So we tell the voice assistant, hey, in this particular kind of scenario, you should do this. It's almost like a contact center training manual.
Yeah.
Hey, if the user is asking for refund for this case, you shouldn't just refund them. You should first ask why you are requesting refunding. And based on the reason, you will triage which reason is actually valid for the refund. So there's a lot of this business process that you wanted to overlay
Yeah.
before you send a query to LLM, because you are not going to just complete it in on LLM to make the business decision for you. I'm sure that a lot of people wouldn't feel comfortable about it.
Yeah. Like in the old way with an intent-based model, it would just the utterance would just trigger an intent, right? It would be the closest thing. So there are a certain amount of things that could happen.
That's right. Yeah.
And as you start using generative models, there's many, many more things that could happen. So you need to apply this like business logic.
Yeah. It's kind of like a two end of the world where the intent model is super precise. Like that you need to exactly say certain things to trigger that certain behavior. But in the Gen AI world, it's almost super blurry that whatever you say, the model has something to say back to you. Sometimes overly smart about it. So you kind of need to find somewhere in between to say that now, what we basically saying is that, based on the context you are being boxed in, right? LM is free to make a lot of judgments by themselves. But you are not going to let LM to make the entire business decision for you, because that's way too risky.
Yeah, that's interesting. So that's like your call center script or processes.
Right.
Your agent wouldn't have a chat about whatever the weather, their family for 20 minutes. So
That's
you
right.
make sure that your models don't. That's interesting. And I think putting the guardrails in before you even send the prompt to the LLM wasn't how I'd previously thought about guardrails. I'd kind of thought of it as something that you were stopping the LLM from doing something rather than taking charge of what it actually gets in the first place.
Yeah. Well, there's also some other second layers of guardrail at the end, but we kind of leaning on the guardrails for
Yeah.
Because once you do it later, you are kind of actually fixing the problems that shouldn't have it at the first,
Yeah.
right? So we're trying to be proactive about the problem to begin with.
Yeah, that's like, again, like if you had an agent on the phone, somebody would say something to them and they would say, "No, I can't do that," or "That's, that's not what we do here."
Yeah,
And
exactly.
just sort of giving that power again. Okay. So we've listened to what the caller has said, we've given that information to the model. The model has sort of figured out, okay, here's what I'm going to do next.
Yeah.
What's the next piece in the tech stack?
Yeah. So, once you give those prompt instructions to the model, then the model can make a couple of decisions, right? So the model can decide this is now the right time to generate, or the information I guess so far is still not sufficient for me to reply to the user's query. So in this case, the model would actually trigger, the function call, or the people prefer to call tooling these days. So that once you triggers the function, this is a programmatic instruction, usually trigger, in as a lambda function, or the API query, so that you can actually send it to a cloud, pull down the information from your user, your CRM system, for example.
Yeah.
Or, you can check the availability of your timetable. Or, a lot of times we actually use those function calls just to write checks about what LLM has already collected. Give you an example is that one very popular LLM is a very, very good at, well, good at that, very prone to hallucinating the function variables. So a lot of times when we say, collect list phone number, even the user doesn't say anything about the numbers or digits, you will just hallucinate a number from 0 to 9, right? So 0, 1, 2, 3, 4, 7, right? So this happens a lot. So we kind of also need a second layer of like triggers that in that case, we tell LLM, hey, don't just assume that you have already collected the number. Please trigger a function so that we can have a supervisor working with you to actually validate this number is valid. And that supervisor is actually just a program that checks exactly, hey, like, a valid number shouldn't be 0 to 9, for example. The valid UK number should be possible, for valid US number should be possible. Whatever you are.
Yeah.
So you can kind of mix the program logic of like very precise logic into a very fuzzy LM, so that you make sure the model is working in your favor rather than actually hallucinating all along the way.
This sounds like a lot of work. Like,
Great.
the idea of generative was that it should make this stuff easier, right? Because we see it all the time, new companies popping up and they've just sort of put this wrapper around an LLM and they say, here you go, build your own voice assistant. Or
Yeah.
sorry. But from what you're saying, there's a lot of work that
Yeah.
needs to go
Well,
in around that.
don't get me wrong, right? I think this is LLM does get things a lot easier.
Yeah.
But then, it's not like, it's not like a fairy tale, like, you just put things together, you magically works. And I think this has been something we have been telling people is that, building a voice assistant is not like, you have a chatbot and you just put voice, at the
Yeah.
front and the back end, and you magically make a voice assistant, right? Never like the case. But I think a lot of this kind of technology is still in a very early stage, right? A lot of people still figure out like what it can do, what it cannot do. So there's a lot of like misconception about like how powerful the system is, right? And I think we are going to come to a realization, like, yeah, like model is phenomenal, right? Super powerful. It's like nothing comparing to what we had previously, but there's still a lot of limitations, right? And we, as a enterprise-facing company, we directly sell these voice assistants to our client, and our clients are demanding a really high quality voice assistant. So therefore, I think one good analogy is that LLM can get you to 70% of what you wanted to do very quickly.
Yeah.
Then the last mile usually is like another, get to 95%, you still need to put in a lot of work and a lot of effort. And that's what our clients is demanding in terms of the quality of the bot that we build.
Yeah, of course, because you don't just want to put something out there that's going to make stuff up, or, if you had a person doing that, well, it'd be a different story.
Yeah.
Okay, so you've understood what the person has said. You've sort of checked that, made sure that makes sense. What's the next piece?
Yeah. Then, eventually, the bot will probably make several tool calls. It could be, several APIs running at the same time, several checks at the same time. But it will keep looping until the bot thinks that it's the right timing to respond back to the user that I got all the information. In that case, the bot would basically respond, generate a response back to the user. One interesting note to say though is the tool calling, right? We get the API, get the API result back. A lot of times these are, when you get the API, sometimes you get a failure or you get a success or you get some sort of parameter from it. We would also summarize these API results into the natural language and then write it back to LLM. So you can imagine it's almost like you have a supervisor whispering in your ear to say, hey, no, that's wrong. Like the number shouldn't be that number. You should, instead, doing it again or repeat the process again. So, but yeah, anyway, the end of it is you generate a textual response, right? And that text response would then be sent to a speech synthesize system. And that's what we call the TTS. And TTS would basically converting text into a voice and then, stream the voice back to the telephony system. And then the user from the other side will be able to hear from the agent.
Yeah. Okay. Wow. There's a lot. And that is just one turn of the conversation. That's the
That one, yes.
customer says, I'm having a problem with my credit card. All of that is happening then.
That's right. Yeah, exactly. There's a lot of, little things running in the background to actually make magical things happen.
Okay, amazing. Shawn, before I let you go, there's a lot happening here. This is a huge tech stack. Will we ever get to the point where there'll be just one single model that does all of this for you?
Yeah, I think so, right? I think end to end, or this is in the research community, we say, one model rules it all, or the end to end, kind of like research the directions. I mean, to be honest, that's not this whole thing is not a new thing, right? I think LLM that people started to research on, since 2014, right? So if you see the technical shift in the past, it always been a case that it becomes bigger model, bigger data set, and to rule it all. That's just like naturally how technology evolve over time, because this kind of language is very hard to model by just writing for the programs, right? And we see that happen with translation models, right? In 2016, we have sequence to sequence for machine translation. In recently, the speech model also get to end-to-end fashion. I just say, the whisper of the world, right?
Yeah.
Although they are not fast enough for real-time speech yet, but it's going to get better, and it's going to get there eventually, because these are the obstacles that we know how to deal with. So end-to-end speech will be there. I think in the next year or two, right? So it's coming. Then you have LLM is already end-to-end, right? I remember when we modeling the dialogue systems 8 years ago, people has been working on modular systems, and that's why we have 3 co-founders. Nicola working on language understanding, Eddie work on the policy management, I work on the language generation. So we kind of have that pipeline.
Yeah.
At the end of my PhD, I was fascinated about this end-to-end conversational modeling. So I have some papers, what that was like very early days. The model was very small and the data set was very small, but we will be able to see there was some, very encouraging results back at that time, right? So I actually published those papers to top conferences back then.
Yeah.
So this kind of end-to-end system, and you see now is LM finally becoming like a production-ready system, and everyone's talking about it. Everyone is using it. So to me, it's pretty clear that end-to-end speech model it's going to happen. Some already like GPT-4o is already the first like product out there started to showcase that capability. We saw a lot of research papers has been working on this in the past couple of years, right?
Yeah.
However, do I think that it will be ready for especially the enterprise to adopt in the near future? I don't think so, because even LM, since we started working on it was in 2015, 16. Now, like we are 8 years in, right? So
Yeah.
it takes some time. But like the thing is, like this kind of model. So once you crack the initial setting of the model and the data, and if it's just a matter of amount of data, the iteration becomes super fast, right? But
Yeah.
you crack that setting to begin with. I think with the voice end to end, I'm not sure we are cracking the entire setting yet. So I think we are still in the early stage of that entire development. But I do agree that this is the inevitable the direction we were moving.
Yeah, great. So with enterprise use cases, I guess, don't wait for that technology because it
Yeah,
could be years, it could be a long way away, but there are ways to get the same result
that's
today
right.
that you would expect. Okay, amazing. Shawn, thank you so much for joining me today. We're going to do a series of conversations about different parts of the tech stack. So everything that you've heard today, Shawn and I are going to dive deeper into each of those pieces. So if that's what you're into, join us again for a future episode of Deep Learning. In the meantime, thanks for joining me, Shawn, and thanks for listening, everyone.
Thank you. Thanks, Kelly.
Bye.